Hello everyone. Today let's solve the problem and colony. Right. So you can read the entire problem and also they have mentioned the examples clearly. So for this input we have to get the desired output. So you can read the entire problem along with the examples. So I'll just summarize the problem for you so that it is easy to understand. So just give me a second. So what the problem states here, mole finds an ant colony. Mole is a name. A mole finds an ant colony with n ants, with each having a strength S1. So we are having n ant, each having the strength. So each ant having the strength S1. So Si. So each having the strength Si. I'll just showing for the sake of example. That's it. So when ants with the specified range is nothing but here I'll consider this one, range L I, comma R I. So when ants with the specific range L and R fight, they earn battle points based on whether their strengths divide each other. So they earn the battle points based on what? Based on whether their strengths divide each other. So an ant is freed if it earns points equal to the number of fights it is participated in. So ant is only freed if it earns the points that is equal to the number of fights it has participated. So if it has participated in 50 battle, then it has to be 50. If there are 50 participations, then it has to earn 40 participations, then it has to earn 40 points. Then only the ant will be freed. That's what they have given here. The task is to determine how many ants mole eats for multiple queries. So we have to determine how many ants mole eats for multiple queries, right? So let's discuss the approach. I'll just come here. Let me delete this one. Here, first thing is, as usual, we'll be starting with the input reading or the input handling. So this basically belongs to the input or input reading or the input handling. So we'll be making use of Node or JavaScript over here, right? So JavaScript or Node. So here, first step is input reading or the input handling. So let's come to the core logic. So let's discuss the main approach. So what we'll be doing here, first, let's understand the divisibility. An ant earns a battle point against another if one of the ant's strength divides the others, right? Hence, for a range of ants, we need to check pairwise divisibility. So we need to check for the here pairwise divisibility. So why we are checking with pairwise divisibility? Here I'll just write div. Pairwise divisibility, right? Why we are checking for the pairwise divisibility? Because an ant only earns the battle point if one against another if one's strength divides the another, right? So for particular range of ants, we need to check the pairwise divisibility, right? So there has to be 2 ants at any cost. So this is one thing. This is understanding divisibility. Nothing but we'll be going with the pairwise divisibility, the second step. And after the second step, what we will do, we have to go with the efficient calculation, right? Instead of checking every pair individually, what we can do, for each query, we can make use of for each query calculation, we can make use of the segment tree. So here, the main approach that we are going with for this particular problem is segment tree, right? So this one you have to keep in mind. We are going with the approach segment tree. So why we are going with the segment tree? Because we don't checking individual pairs for each query will be inefficient. So we can make use of the segment tree instead to store the information about the strengths and calculate the results more efficiently. So we are going with the segment tree. Why we are making use of segment tree? To store the information about strengths and calculate the results more efficiently. That is the reason we'll be going with the segment tree. So after efficient calculation, we'll be going with the segment tree construction. Segment tree construction, let's discuss the segment tree construction. So we'll construct a segment tree where each node maintains a GCD, nothing but the greatest common divisor. So each node in the segment tree, so if this is like, so here, so these are nodes, right? These are nodes basically. Leaf node, this is the parent of this one, this is parent or root node. So what they are saying is here, we'll construct a segment tree first where each node maintains the greatest common divisor, nothing but here for these two, this one will be GCD. I mean, for this one, this will be GCD. So each node, so this one, yeah, GCD. So it for each node, yeah, will maintain the greatest common divisor of the strengths, and the count of the strengths equal to this GCD. So this we have to keep in mind. Why we are making this one GCD or the greatest common divisor? So this will help in efficiently determining the GCD of any queried range. That is the reason. So here this is nothing but segment tree construction. So segment tree construction. So we are setting this one with the greatest common divisor for each node, right? So in this step, so we'll understand the step number 4 while we write the code. So you don't have to worry too much. Just understand the concept that we'll be going with the segment tree construction, and we will be for each node we will be setting the greatest common divisor for the strengths of the strengths, right? So and also we'll count the count of strengths has to be equal to this GCD itself in this step. So finally, after this one, what we will do, we have to process the query, all the queries, right? For each query, we can retrieve the GCD for the range. So here, this is nothing but processing queries in the 5th step. So we, instead of going for the determining the each query step by step, what we'll do, we can retrieve the GCD for the particular range. So that's how we will process the queries. For each query, we can retrieve the GCD for the range. The number of ant mole eats will be the total ants in the range minus those whose strengths are equal to the GCD. So this we will see while we write the code, 5th step. So finally, we'll get the output in the after processing the queries, we'll get the output in this step, 5th step, so that we will be displaying in the output. So to display the output, we'll be making use of that. To print or display the output, we'll be making use of the console log in JavaScript. So this will be the last step. So overall approach we are going with for this particular problem will be this one. We'll be making use of the segment tree. Also, we'll be going with the we'll be setting the GCD for each node. And finally, we'll be processing the queries. And after processing the queries, we'll be printing or displaying the result using console log or the output, the last step. So let me delete this one. Let's start writing the code so that we will understand this better. So first step is, as usual, we will import the file system module for reading the input. So I'll just give const fs equals require of fs. So this is one thing. Second step is we have to read all the input data at once, right? That is the reason we are making use of the file system module. Instead, or else we would have went with readline module. So why we are making use of the fs module? So that fs module or the file system module allows us to read all the input data at once, and also will split the line so that we have to read the every single line or every individual lines we have to read, right? Also, we have to read the eliminate the unnecessary spaces that is in the input. So this line, for that purpose, eliminating the spaces, I'll be making use of trim, right? So I can write this one in this way. I'll just give input equals fs dot read file sync. Let's start from 0 and we'll set the encoding to UTF-8. Also, to remove the unnecessary spaces, let's make use of the trim. And to read the input line by line, I'll just make use of the /n, right? So So here this will be, let me make use of this one regular expression instead. This works. So here it will be /n /r then plus this one. So this is fine. This is first first step. Then let's initialize the counter to read the numbers from the input. Nothing but we have to go on reading from first line, second line, third line input. We have to read each individual line, right? Line by line. So that is the reason we'll initialize the count to 0 initially. So I'll just create the custom function named readNum, and I'll just give here input. We have to read line by line, right? We have to read the input line by line. So this will be, let's increment the count. Also, if there are distinct numbers here or distinct characters we have, in this case we are going with numbers, I believe. Yeah, if there are distinct numbers here, then there has to be space between them, right? So for that one, I'll just make use of split and space. Also, let's make use of map. I'll just say take some random character, just give +a for reading. So this is fine. So after this, let's write the function to create the segment tree. Nothing but yeah, we are creating the segment tree. I'll just give the function. This time I'll just give segment tree of parameters. I'll just take array. So ARR I'll just consider. So let's initialize the tree array. So I'll just give here, let variable name tree I'll just consider. Let's initialize the array. This one, new array of 2 into length of the array. Nothing but ARR I have considered right here. Parameter. This will be length of the array plus 1. Along with this one, we have pair of ends every time. So here it will be 0, 0 initially. So did I miss anything here? Oh, this one we have to display this one within the array, right? So yeah, this is fine. So then let's build the segment tree. So for building, I'll just make use of build. This one will be tree, ARR, the parameter. Finally, we will return the constructed tree. Nothing but I'll just give return tree. So this is fine. So this is the function to create the segment tree that we have written. After the construction of the segment tree, we will be building the segment tree from the input array. So similar to this one construction, we have to build, right? So I just give function. Well, I'll take 2 parameters this time. One is tree and another one is array. So sorry, what happened to this? So yeah, here let's start. Let's iterate here. I'll just give for let I equals 0, I less than length of the array. Here I'll give I. Let's increment the I. So here leaf nodes will be value and count, right? So for that purpose, I can just write like this: I index plus length of the array. This one I can set this one too. Did I miss anything here? This has to be I plus array length. So why this one? Yeah, I can initialize this one too within the array of I, and also we can set this one to 1. So why this one? Leaf nodes we have to get, right? One is leaf node value and another one is count, leaf node count. So that is the reason we are writing like this. So next step is we will be building the internal nodes by merging. So we have to merge the internal nodes, right? That we have to merge the internal nodes. So that one will be building. So we'll be building the internal nodes by merging. So again, I'll just make use of the for loop. This will be let I equals length and I greater than 0. This will be I minus. So reverse iteration. So next, let's merge the child nodes. Iterated value of the tree, I can just consider like this. So here, merge of, so merge, this one, I think I have not written the merge function yet. We will be writing this one in the future. So we have to merge the child nodes. So I'll do one thing. I'll just leave this one for now. After writing the merge function, let's merge the child nodes. Let's come here and merge the child nodes, right? So for now, what we'll do, just give me a second over here. So let's write the merge function, nothing but function to merge the two nodes in the segment tree. So how can I'll just give the name of the function merge itself. The parameter I'll just take T1 and T2. So we have to merge the two nodes, right? T1 and T2 I'll consider. If here T1 of 0, if the value is equal to 0, then we will return T2. So the same goes with T1. I'll just copy the same line and make the necessary changes. So let me copy this one here and here. This one is if T2 of 0, then we will be returning T1. So next step is if the values are same, then we will sum the counts. Then we will add or sum the counts. Nothing but if your T1 of 0, this one equals to T2 of 0, then what we will do, we will return one is T1 of 0, T1 of 1 plus T2 of 1. This is what we will be doing. So if values are same, then we will sum the counts. Then if T1 divides T2, then we will return T2, same thing, vice versa. If T2 divides T1, then we will return T1 in the next two steps. In the next two steps, that's what we'll be doing. See here, we can write in this way. T1 of 0, T2, 0. This one is equal to 0. Then we will return T2. Also, if T2 divides T1, then we'll be returning T1, right? So I'll just copy the same thing and make the necessary changes. So I'll come here. Let me give here. If T2, T1, if it is equal to 0, then we will return T1 instead. So finally, what we'll do, otherwise, we will return GCD and count 0. So I'll just make use of we have to return, right? Let me make use of return statement. And within the array, we have to display. So I'll just write GCD of T1. This will be within 0 along with T2 of 0. Comma, initially we'll start from the 0, right? That's what I'll be mentioning here, 0. So this is fine. This is it for the function merge. So we have written the function merge. Let's, here I have left the space, right? So we have to merge child nodes here in this step. So iterated value of the tree will be merge of tree I. This will be 1. Oh, this has to be within the array. I missed this one here. Sorry. This has to be within the array, not common brackets. So again, it will be tree. So here I can write again the same thing, right? Same operation we are doing here. Or let's make use of the or operator. Yeah, we'll go with bitwise or. Then this will be fine. We have merged we are just merging the child nodes. So I hope this is clear till here. next step, what we will do after writing the function to merge two nodes in the segment tree, we have to calculate the GCD of two numbers. So calculating GCD is simple. We'll just go. We can just write GCD. I'll just take two parameters, nothing but A. So we are calculating the GCD of two numbers, right? So I'll just make use of the while loop because B should not be equal to 0. Then only we have to further continue. So here, let me give let temp equals A. This has to be B, right? B equals A module B. Nothing but this is the greatest common divisor logic using the Euclidean algorithm. This one, B equals A module B. Assigning temp to B and B equals A module B and A equals temp. This is nothing but Euclidean algorithm. So I'll just give A equals temp here. So here this is fine. Finally, what we will do? We will be returning A. We'll be getting the GCD here. So this is fine. After calculating the GCD, nothing but writing the function to calculate the GCD of two numbers. What we will do? We will write the function to get the GCD for a specific range in the segment tree. So while discussing the approach, I had said that we need to. So we'll be calculating the GCD first for only one reason. That is, we have to calculate. It will be helpful when to get the GCD for a specific range in the segment tree. That is the reason we'll be writing the function to get the GCD for a specific range in the segment tree. So I'll just come here. Let me give the function name range GCD here. This time the parameter I'll take is tree, left and right. For that one, I'll just take AL and AR. So AL is nothing but, so here we will be adjusting the index for the segment tree. Also, we'll be adjusting same thing, index for the segment tree for the upper bound. So I'll just come here. Let's do this first thing. This will be AL equals AL plus length of the tree minus 1, the last index, right? This has to be length of the tree minus 1, nothing but the last index, and I'll just make use of this one. Right shift operator. Bitwise right shift operator, right? So we have to skip this one while I make use of this operator. So we are adjusting index for the segment tree. Same will do with for the upper bound, right? So I'll just copy the same thing and make the necessary changes. I'll come here. Let me make this AR. Dot length minus 1. This is fine. This is same, right? So next initial result, I'll set this one to result equals 0, 0. And nothing but this is the initial result. So we'll be storing the main result here itself in this array itself. So let's go with the while loop. If AL less than AR, then what we will do? We have to merge the left node as well as the right node. Also, we have to move up in the tree, and same for the upper bound. These four things we have to do. First, let's merge the left node. So here is AL 1. I'll just give result equals. Let's make use of the merge function. So here this is recursive, right? So this one will be tree within the array. We are doing this one. The same thing I'll do, and same thing I'll copy and make the necessary changes for the right node as well. So here we are merging the left node. Next step is merging the right node. Here instead of AL, this will be AR. This will be result. This one we are incrementing the AR. Here we will be decrementing the right AR. Right. So this is fine. I hope this is clear till here. Next, we will move up in the tree. After merging left and right nodes, we will move up in the tree. Also, same goes with the upper bound as well. Nothing but AL and AR. So here we can write this one in this way. AL equals 1. Nothing but we are moving up in the tree. This one AR, that's also same. Same goes with the upper bound as well, right? So finally, after these steps, we have to return the result. So we'll be getting result here, this one, right, in the res. So I'll just return res. So I hope this is clear till here. Next step is we have to read the inputs. So only reading the inputs is left. After reading the inputs, so yeah, I have forgotten the last step. We have to process each query as well, right? For that, we have to take the for loop and process the each query. So reading the inputs and processing the each query is left. So let's start reading the input. So I'll just give here n equals, we have written the custom function read now, right? So I'll just make use of this. Let s equals, again we'll be reading this one, read now. Here we'll start with n, we'll start with 0. Here just we will read this one. Let t, for n and t will start with 0, right? So here this has to be read now 0. This is fine. Next, let's construct the segment tree. Constructing of the segment tree, I can just write here tree equals, we have already written this function, make segment tree of, within that one parameter. Yes, I'll just take this one. So let's start processing the each query now. So initialization is done. Let's go with the iteration. So this one will be I less than c. I'll just increment I. Finally, let's read the query range as well, right? Each query should have the particular range. So that is why, and we are setting that one to the greatest common divisor at each node, if you remember. So I'll just make use of the destructuring operators instead. So here this will be L, R. We have to just read. Again, I'll just make use of the read now. So what we are doing here, we are just reading the query range. So that is fine. Finally, the final step is to, we have to calculate and output the number of ants that mole eats, right? So this will be process dot, and just make use of the std out. So dot write, this will be r minus 1, r minus l, right? L plus 1 minus, let's make use of the function range gcd. Within this one, parameters will be tree l minus 1 comma r. So this is fine. After this one, it will be 1. We'll start with 1 and just give me a second here. We have to do this for the every line, right? So I'll just make use of /n as well here. I hope this works. Let's see. So yeah, this is it. Now let's check with the input, right? So for this input, we need to get the output 4411. Let's check with the input. So let me hit on run. So we are getting the output 4411, right? So the code works absolutely correct. Just give me a second here. So let me make use of this. Let me come here. Let me click on submit code. So here it will be, I'll choose F. Let me paste this one over here. Let me click on submit. So let's wait for some time. So here you can clearly see the code got accepted here, right? This one and colony. So the code got accepted. So this code works absolutely correct. So this is it. Thanks for watching, guys.